Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thanks so much for joining me for another video in the Rust programming tutorial video series. You can check out the full playlist of this tutorial series on my video channel at youtube.com/Trevor Sullivan. If you head over to the featured playlists down here, you can find the Rust programming tutorial playlist. And you can also go to the playlists tab on my channel and see the Rust playlist along with several other playlists that I've made available. So if you like this video and the other content on my channel, make sure to leave a like, subscribe to the channel. That really helps support the channel, leave a comment, and help others to find these videos as well. So the topic today is going to be on the Rust Inquire crate. Now, the Rust Inquire crate is a crate that helps us to prompt for user input into our application. So imagine that you're building an application that maybe deploys cloud resources. Maybe you're building an application that writes data or updates data inside of something like a MySQL database.
Hello and welcome to Rust Programming Language Full Course for Beginners. In this course, I've put all of my effort to teach you everything you need to know, explaining the core concepts and the principles ruling Rust language so you can start programming in no time. And before we get started, I hope you're finding these tutorials and courses helpful. I love creating these resources and sharing them with you all for free. If you have found value in my work, and would like to help keep this content accessible for everyone, you can join our community on Patreon or simply buy me a coffee to keep me fueled. Thanks for being part of our learning community. With that out of the way, let's go ahead and start our course. The first question you might be thinking of is, what is Rust? Rust is simply a systems programming language like C and C++, used for building operating systems or game engines, which means that it's a compiled programming language. Compiled programming language simply means that the language itself uses a compiler, some sort of dynamo or machine that translates what you write into machine code so your computer will understand and translates into different actions. Rust actually has started as a side project by Graydon Hoare in 2007. He named it after the rust fungus, and then it was sponsored by Mozilla Company in 2009. But the first version of Rust has appeared in 2014. Now, for some reason, Rust programming language has been the most admired language for 7 consecutive years, according to Stack Overflow Developers Survey. You can see here it says that Rust is the most admired language. More than 80% of developers that use it want to use it again next year. To be exact, it's 86.1% of 65,000 developers voted for Rust as a language that they want to use again next year. And those who get the opportunity to use Rust have fallen in love with it. Compare this to something like MATLAB. Less than 20% of developers who use this language want to use it again next year. Only less than 20%. In contrast to Rust, where more than 80% of developers want to use it again next year. And you can see that JavaScript, Python, TypeScript, HTML, CSS, SQL, and Rust. But do not be fooled, because we are judging by this red circle. And you see that Rust's red circle is winning by a big margin. And some of the biggest companies in the world actually are using Rust, like Dropbox, Discord, Go, NPM, Amazon, Mozilla, Facebook, and Microsoft, just to name a few. That's great and all, but we want to know, what is the secret behind Rust? Why do developers love it? We want to know. Microsoft, just to name a few. That's great and all, but we want to know, what is the secret behind Rust? Why do developers love it and companies prefer it over other languages such as C and C++? And believe it or not, the White House actually has suggested that companies must switch from C and C++ to Rust programming language. That was a few months ago in February. It turned out that the reasons behind that love to Rust, and remember that Rust is a systems programming language like C and C++. The secret here is that Rust tries to do what's being very hard and difficult for a lot of programming languages, which is finding the balance between speed, safety, concurrency, and portability. If we'll talk about speed, Rust is fairly comparable to C and C++ in terms of speed. C and C++ are low-level programming languages that execute in no time. They are very close to machine code, and they're so close to your metal, to your hardware, because the compilation between C and C++ to machine code is blazingly fast. Rust is actually comparable to that speed. Number 2, safety. Most of the low-level programming languages like C and C++ are very fast in compiling to machine code, but with that speed comes on safety. They are not particularly safe, and when I talk about safety, I mean safety in memory management. And don't worry, we're going to talk about safety in details throughout this course. Number 3, concurrency, which means multi-threads can run in parallel if you decided to design your application this way. Sure, there are bugs like data races and dangling reference errors, which I will explain in details in this course. And finally, portability. This is where we say that you can compile once and run everywhere. You turn or you compile your Rust file into an executable file, which is going to be portable throughout all the other systems. Whether it's Windows, Linux, or Mac, you can be sure that your program is going to work on those systems. So for example, you have high-level languages like Python. It provides garbage collection for better memory management control. And don't worry about those terms, I'm going to explain that in details when we reach the ownership chapter of this course. And then you get low-level languages like C, providing functions for memory allocation. But it turned out that those functions are not the best solution for memory management. Now Rust doesn't have garbage collection, nor it has functions for memory allocation. Instead, Rust uses concept called ownership and borrowing. This is going to be discussed in details in chapter 4 and 5. Rust also has a package manager called Cargo, and Cargo is similar to npm for Node or pip for Python. Now let me show you Rust website, how we can install Rust very easily, and I will show you how we can print first hello world program using a simple file and also using Cargo to create our first project. Alright guys, so what you need to do is to go to your browser and type rust-lang.org and you will find this page. And here you will find everything you need to know about Rust, so it's a language empowering everyone to build reliable and efficient software. Why Rust? Because of the performance, reliability and productivity. Down here below, build it in Rust, so you have here some building tools like command line interface, WebAssembly, networking, or embedded. If you like this low-level control through
Here at Cambridge Consultants, we work on around 300 different software projects in a year. And increasingly, we're looking at this next generation of embedded devices. here it is. And that's primarily being driven by technologies like NB-IoT and LoRa. And these devices have an interesting security problem. Because they're connected, they need regular security updates. But because they only have low bandwidth connectivity, those updates can be difficult and expensive. Traditionally, embedded devices are programmed in C or sometimes C++, but wouldn't it be better if we could use a language that avoided a whole class of problems that lead to these security issues? Problems like null pointer dereferencing, buffer overflows, race hazards in multi-threaded code. Well, actually, there is a language today that helps us do that, and that's Rust from the Mozilla Foundation. And this is a language that will compile down to machine code for your favorite ARM microcontroller, but it's able to give you all of these guarantees. So all of these problems just can't exist. They're not allowed by the
semi-hosting, panicking and all that kind of stuff, working with the hardware, no problem there. Rust is going to help you. Next, we have Rust in production. So you have here hundreds of companies around the world are using Rust in production today for fast, low-resource, cross-platform solutions. NPM is using Rust, as we said, Yelp, so you can get involved, you can read Rust, that's your main resource. So this is very important. You can read Rust, watch Rust, and contribute to the code because it's an open source project. Also, this is very important. The Rust book is your guide, your friend while learning Rust programming language. The documentation, so you have here the standard library, edition guide, cargo book. So you have here everything has a book. So Rust C, that's the compiler. You can read that and familiarize yourself with the knobs available in the Rust compiler. You can read for cargo for the package manager. This is edition guide, so for the guide to the Rust editions. The standard library, that's very important also, that shows you everything from the macros, the modules, the functions, and everything you can search for inside here, inside the standard library. Build your skills in an application domain, so command line book, WebAssembly, and embedded. So they have everything in that website. But what we're interested here now is to install Rust on our local machine. So you will click on install. So you have install Rust using RustUp. So that's the recommended way. If you're working with Linux or Mac, you can just copy that curl link and paste it to install. Or even if you're working with Windows Subsystem for Linux, you can do the same thing. Otherwise, you can go and download the RustUp int.exe. You will run that and everything will be fine. It's going to be installed in no time. It's very easy to install the RustUp. Once it's installed, let's go now and check out. If we have Rust installed or not. So if you will do rustup -- version, And you can find here that it says Rust Up version 1.27.0. It also tells you here that the currently active Rust C version is Rust C 1.77.1. To verify that Rust compiler also has been installed successfully, you can do Rust C version, and there we go, we have 1.77.1. Also, you can check out cargo, so you can do cargo version, and we have also cargo version 1.77.1. Alright you guys, so I want to show you how we can print a simple hello world program in our terminal. So I will create a folder and I will call it Rust Hello, and I'm going to cd to that, Rust Hello, and I'm going to open this with Visual Studio Code by typing code space dot to open Visual Studio Code inside that current folder, inside that current directory. Just hit enter and Visual Studio Code should be open to you. I'm going just to bring it over here. And the first thing that you would want to do inside your folder is to create a file. I'm going to create this file hello.rs. RS is the extension for Rust programming language. I'm going to hit enter, and there we have our first code line in Rust. So the main entry point in your Rust file is main function. To define a function, simply you will type fn and the name of that function. It should be main. Followed main, we will have parentheses. Now you do that. So you will get outside of the parentheses and you will open curly braces. Inside the curly braces, you would want to print hello world. If you're familiar with languages like Python or JavaScript, in Python you would do print and then you will pass the string of the letters that you want to print to the console. In JavaScript you would do console log for node and so on. Verb. Print line with an exclamation mark followed by parentheses, and then inside the parentheses, starting by those double strings, inside the double strings, we will have whatever the words that we want to print to the console. Now, I will hit Ctrl S to save my file. I will open my integrated terminal by hitting Ctrl and tilde. And then what you want to do here is to type simply Rust C, which stands for Rust compiler, followed by space and the name of your file. In our case, our file is called hello.rs, so we will need to type hello.rs. If you will hit enter, notice that nothing actually has happened. Why is that? If you will come here to the Explorer, you will find that the Rust compiler actually has compiled your Rust to an executable file, which is hello.exe. This is invisible, of course, because it is zeros and ones. As a matter of fact, you don't have to see it. The most important thing is that Rust has compiled your Rust file with no problems, with no compiling errors. What you want to do now is to run that executable. So if you will come back here, if you will do /hello and hit enter, you will get hello world printed to you with no problems. Now there is another way to do that using Cargo Package Manager. To do this simply, we want to use Cargo to initialize a project. So what you want to type is Cargo new and the name of the project. Let's call this project Hello Project, for instance. Notice here that created binary application, which means that no problem there, Cargo has created your Hello project folder. Inside the Hello project, we have different files and a folder called source. Cargo.toml for the settings for your project. You see here the name, the version, and the edition. And if you want to add some dependencies for your specific project. Also, you will have .gitignore. Inside the source, the main file is main.rs. And notice that it has the same exact main function that we have manually typed in the last example. Let's actually change that. Let's say hello Rust from Cargo, and I will hit Ctrl S to save. And what you want to do is to change directory to hello project folder. And now you're ready to run your project by typing a simple command, which is cargo run. You will hit enter. It compiled, and you can find here that hello Rust from Cargo. Now let's say, for example, that I want to change in that hello Rust from Cargo, and I want to add, for instance, instead of Rust, I will add a crab. If I will hit Ctrl S, and if I will do cargo run again, now you can see that hello and the crab from Cargo has been applied directly. Now, let me show you something very interesting and you need to be aware of. Let me show you if we will go to our file that we have created, which is hello.rs. And I will click on hello.rs. And if I want to change hello world to hello crab. Now let's do Ctrl S to save. And let's do /hello. Hit enter. You'll find that nothing actually has changed. And that's because you have to compile your code every time you do changes. So you would use rustc again to compile the hello.rs in order to apply the changes. And now if you will do /hello, you will find that the crab has appeared and the changes has been applied. That's a very important point when you create manual files, not in projects. The project itself compiles every time you do cargo run. But in the simple applications written in Rust files like we have done here manually, we have written the main function manually, you need to use the Rust compiler after every time you make some changes. And that's it for the introduction for Rust programming language. Thank you so much for watching. In the next part, we're going to study primitive data types. Hey, what's going on? My name is Amir and this is BigBrace channel. Today we're going to study together the primitive data types in Rust programming language. As you know, Rust is statically typed programming language, which means that you need to define the data type of the variable you're declaring. The primitive data types are also called scalar data types, like the int, the float, the boolean value, and the char. These are the primitive data types. So let's take each one independently. Let's take together the integer. So Rust has signed and unsigned types of different sizes. The signed, which means it could be plus or minus. They are i8, i16, i32, i64, i128. These are signed integers, could be plus or could be minus. They can hold positive values or negative values. However, the unsigned integers hold only positive values. They are u8, u16, u32, and so on. So let's take a look to an example together. We'll create the main function. And I will have x. And x is going to be of data type i32. I'm going to explain to you what is i32, what's the difference between 8, 16, 32, 64. For example, we'll take the difference between those, but the concept is the same. Basically, the main difference lies in the size and the range of the values they can represent. So the smaller the number, the smaller the size and range they can have, and the bigger the number, the bigger the size and range they have. This is in brief, but I will talk a little bit about that in a moment. So x is going to hold value of 42, so it's i32. This can be, by the way, negative. It's okay. And also we can have y, and this variable is of data type u64, for instance, but in this case it should only hold a positive value, okay, because it's u. Okay, it could be u32, u64, whatever. And let's print together. I'll say signed integer, and this is the placeholder, and here I want the x, and the same for the y. So here unsigned integer, and we want the y. Let's take a look. Okay, now we have the executable file. Let's run the main, and we'll have signed integer -42 and unsigned integer 100. What will happen if I will put in the positive value a negative value here? Let's do rustc main rs again, and we have a compiling error. Let's take a look what the compiler says. It says here cannot apply unary operator minus to type u64. Okay, that demonstrates what we're saying. So let's remove that. Let's save, run again. Basically, the i32, it can take 32 bits of data, and this here can take 64 bits of data. But what else? The range. The range for the i32 can vary from 2 to the power of 31 in negative value to 2 to the power of 31 in positive value. While the i64 from 2 or -2 to the power of 63 to +2 to the power of 63. And let's take a look quickly. So let's say let e have 32 with the maximum value of, let's take this one. Okay. And also let's do here for the 64. And both of them are the largest positive values. More than that, you will have a compiling error. And we have printed everything. So let's go ahead and check that out. Let's compile everything. So good. We don't have any compiling errors. Good. Maximum value of i32 and maximum value of i64. What will happen if we'll increase this, for example, by 9? And here we'll increase it to 8. Save that. Run again. And we have a compiling error. We have the literal, this number does not fit into the type i32, whose range is this. So this is the maximum. Okay. And the same case goes here. We have changed to 9 while the maximum should be to 7. And it says here that consider using u32 and u64. The main difference, actually the u32 and u64 are a bit larger than the i32 and i64, but not by much. Okay, it's just the compiler is suggesting what you can do in this case. If you have more number of bits to be allocated to a certain variable, but in case that it's not fitting to that data type, you should change the data type, or you should consider using a larger data type. In this case, it could be the i128, for instance, if i64 is not enough. So u64 and u32 are larger. The whole thing actually from u8 to u28 are a bit larger than the i8 to i128. And that has to do with the power. So if the I is 2 to the power of 63, u is 2 to the power of 64. Okay, so that's as far as the integers. Let's go now and take a look to floats. The floats simply represent numbers with fractional parts. I think you know what a float is. So we have only two. We have f32 and f64. These are the floating point types that we have in Rust. And now let's take an example. So let's create the famous pi. That's going to be of data type f64. That's going to be 3.14. And let's print that, and we'll say value of pi. Okay, let's take a look. Okay. And we don't have any problems. Value of pi 3.14. Next we have the Boolean values. So Boolean values, as you know, are whether true or false. So let's have an example. Let is snowing of data type bool, that's the data type, BOOL, equals to true. And be careful, true is not capitalized. I mean, the T is not capitalized. Don't forget the semicolon. And let's do print line. I will say here, is it snowing? And we'll pass here is snowing. All right, let's run that. Okay, we didn't have any compiling errors. Is it snowing? True. And finally, we have the char, or the character type. And the character type actually represents a single Unicode scalar value. Okay, so that's a Unicode character type. So for instance, letter X, letter Z,